Oh, hello, welcome to our webinar. And today's topic is EMX meets SMARTColor. And today I would like to show you how you can extend your benefits of your Moldbase design with an automatic color coding. Okay, let me first introduce myself. So I'm Thomas Schneier. I am responsible here at B&W Software for Expert Moldbase extension. And I have support from Sascha Möller, who is also working on the EMX team, and he will later tell me your questions, and together we will answer your questions. And he will manage everything in the background, that everything works fine here in the webinar. I've prepared a little agenda here. I would like to start with some explanations how color coding with SMARTColor and EMX works. Later, I will show you how this can be done in the Creo Parametric environment with a live demonstration. And in the end, if you have questions, we will have a Q&A session. You can also write down all your questions in the chat. So in case it's a relevant question, then Sascha will also tell me a question. Then we can also answer the questions in between. Okay, so for all who do not know EMX, so EMX is short for Expert Moldbase extension, and it's the Moldbase design software for Creo Parametric. And yeah, it's developed here at B&W Software. And why do people use EMX for Moldbase design? The biggest advantage is that they can assemble different types of standard parts from a large variety of suppliers. For example, German supplier Hasco or the Austrian supplier Moisburger, but also other standards like DME, which is from the US, and many more. So this is the main advantage you have, the standard parts available, and you can directly assemble them as Creo parts. Yeah, what kind of parts can be assembled with EMX? Of course, for Moldbase design, you need the Moldbase plates. And yeah, there are other types available like screws, standard screws, shoulder screws, but also for the ejection of the mold part, you need ejector pins, you need guide components, or even cooling components for the cooling circuits. And yeah, it's great that you have these standard parts available, but on the other side, it's also necessary that you can create standardized cutouts within the interfered plates or other components. On the right-hand side, you see this guide component, and this guide component interferes with 3 Moldbase plates. And of course, you need different bores inside these plates to assemble the guide component. And that is also a big advantage of EMX, that you can automatically create these standardized cutouts for any type of standard part components. Okay, so what has changed in our latest EMX version to make it ready for color coding? So far, we only created the cutouts, so only the geometry of the cutouts. And what we now introduced is that we introduced a new parameter, which is called EMX under surface under function. And this parameter can have different standardized values, and these values, so this parameter is added to each surface inside a cutout, and every surface will have a standardized value which describes the function of this surface. So yeah, this is a little theoretical So let me just explain this in a tiny example that everyone will understand. So I have prepared a tiny example with a screw. So even if you're not a mold maker, you will understand this example. Here you see a simple, two plates that are fixtured with a standard screw, and the screw also has created several cutouts inside these plates. And here you see highlighted in green color the surface of the counterbore. And on the right side, there is also the standard parameter dialog visible. And I have selected here the surface. And at this surface, you will find this new introduced parameter called EMX surface function. And the value of this parameter is cylinder under counterbore. It's in German, but I think you will know this dialog quite well. So yeah. I will switch to the second surface here, highlighted in the green color. And here we have another value for this surface function, and it's called plane counterbore. So it's the bottom surface of the counterbore. The third surface that we have in this example is the through hole of this screw. And this value here is called cylinder under bore under 1. So this just tells EMX that this is just a through hole and with nothing, not a specific functionality. Okay, and the last surface that we have is the core hole of the thread. So this value here is cylinder thread core hole. Okay, so this was just the example for a screw, but of course there are many other functions of surface that can come up in several cutouts that are created with EMX. And if you are interested in these surface functions, we have created a blog post on our homepage. And this blog post explains you all the different values that we just introduced to make it ready for SMARTColor. I will just switch to this blog post. You can find it here. It's called designated surface function for cutouts. The link is also included in the presentation, so you will find this blog post quite easily when we send you the presentation. And here is a tiny explanation in the beginning, and then you will have just images with the usual EMX cutouts that are created, and with some colors and with the designated values, you can just see what values the surfaces have. Okay, so you have this here for cooling components, for O-rings, and all other components that can show up. So here we have ejector pins, and on the bottom you will also find the values for guide components and so on. Okay. So let's go back to my presentation. And now the second question that arises is, how can we now convert these parameter values into colors? And as the topic of this webinar already explains, so we will use SMARTColor here. So SMARTColor is our tool to designate values to surfaces, and to make this possible, we just introduced a special or customized SMARTColor configuration for EMX. And you can download this configuration from our website if you are interested in this configuration, if you want to test it. And what do? We now assign RGB colors based on the parameter values that we just created during the design of the Moldbase. And we used the color coding rules of the VDWF. So this is a quite known association of German mold makers. So these guys sat together and they came up with a standardized color coding rule set. And we just decided that this makes sense as an example because it's a standard which is not just for one company. So it's for, yeah, it's for mostly mold makers, but yeah, maybe it's also relevant in other parts of the world as well. Or even if you have your own standards, you can also adapt the current configuration to these standards. So the last point here on this slide says that you can adapt also to any company standard. Okay, so if you have your own color coding company standards, how you work, you can also use these customized SMARTColor configuration as a template and yeah, change just the color rules. But it's yeah, can be used as a template. Okay, so if you apply now the colors with SMARTColor, here for our screw example, you see that there are two different colors assigned in this example. And yeah, this green color basically says this is a Moisburger roughing standard. So this means this FDWF standard is also used by the Austrian supplier Moisburger. So if you send out the colorized parts to Moisburger, they will ship you the part machined based on these standards. Okay, so green color means Moisburger roughing, so it's a FDWF drilled hole. And the second color, the yellow color, means that it's a metric thread, so it's a standardized thread based on the diameter of the core hole. So that's what it says. Okay. Okay, so then I will just start with my Creo live demonstration. So I have basically 2 points that I would like to show. I would like to show you how you can apply color coding rules based on a configuration. And the second point will be in case surfaces are not covered by this color coding rule set, you can also apply colors manually, okay, to finish the part, the color. Okay, so then I will just switch to Creo Parametric. No, this was not Creo Parametric. Okay, so here we are. Okay, so I will create a new project to show you how this works if you really start a project from scratch. So I will switch to the EMX tab and say create new project. And yeah, basically it's not important what the project name is, so we just use the default values. And now we have an empty new Moldbase assembly. And to speed up the assembly definition process, I will just use here this recipe type 1 from Moisburger, which basically contains a Moldbase stack with a couple of plates and a couple of guide components and clamping screws. So all plates are assembled, the dimensions are set to the correct values, and yeah, just some default colors for the plates are set up. And now we are done. Okay, so this is my default empty Moldbase with just a couple of plates. And to explain you how these rules work, I will assemble a cooling component because it's quite easy to explain the rules with this example. So let me just create a new point. And then choose EMX component cooling components. And now I will select the E2007-2 seal plug. I have to select another size with the diameter 12, and yeah, I'll select my references, point and surface. Now we have to tell EMX how deep the drilled hole should be. And then we can assemble the component. Okay, quite fast. Okay, so now here we have the seal plug. We created a hole, and now we'll have a look to this component. So I will open the plate. The plane has already a couple of features predefined, so the guide holes, and here we see in the model tree a UDF was created called cool single counterbore, and this is related to my Moisburger component. So if I have a look to the parameters which are written to this UDF group, you will find several values, so which tells me what's the source of this cutout. So it's here this BNW under component value is E2072, and the supplier Moisburger, and the type is the cooling. Okay, so this will be relevant for our rules later on if I explain you this a little bit more in detail. Okay, if I go to the parameters dialog, move this a little bit to the side, so I can now choose here from surface. So I can select now a surface and have a look to the surface and what parameters are assigned to this surface. So if I choose this counterbore surface here, I have to rename it, otherwise I cannot see the parameters. Okay, I'll see now here the parameter EMX surface function, and the value is cylinder counterbore. So this is how this works. If I choose the surface here in the middle, it's called cylinder bore 1. So these are the values that are necessary to describe the functions of this cooling bore. Okay, so now we have two aspects. One is the surface parameters, and the others are the parameters at the group. And yeah, if I now go to SMARTColor and say apply rules, I will now use SMARTColor and trigger this colorizing process. Okay, I select these EMX SMARTColor manufacturing active context. So this context that we just introduced contains all tolerances. Okay, so colors that describe a tolerance. And we see here the green color that was already described inside in the presentation. So it's the FDW drilled hole, and others like these metric threads. I can now select apply. So the whole part is colorized. Okay, so not only my hole, but also the already predefined guide components, for example. And we see now that there are two different types of colors assigned here to my cooling bore. So it's not only a counter bore, but there is also another surface here. This purple is used to colorize it here at the counter bore. So this means Moisburger tells us to use a different tolerance for the counter bore surface than for the plain counter bore surface. Okay, so this needs a different accuracy. Okay, so how does this work now? If I go to the content manager, as an administrator, I can now work on my rules. So here we see these EMX SMARTColor manufacturing rules. And in the available contents, I can now go to rules. Okay, I see here a whole bunch of different rules. And we will find here this Moisburger roughing rule, for example. And if I double click on it, I see here, here's my green color, the drilled hole. And the drilled hole rule is applied with different criterions. For example, we have the criterion here, if the parameter name equals EMX surface function and the parameter value equals cylinder counterbore, please use the green color. Same here. If it's plain counterbore, please use the green color. And what else is important for my cooling bore? In case the end of the parameter value is under bore under 1, then please also use this green color. Okay, so in my example here, I have now my plain counterbore surface and the cooling core hole, which applies to these green color rules. So the question is now, why is there another color used for the cylinder counterbore in this case? So it's possible to write even more detailed rules. For example, this one here. So we have this cooling E2072. If I go to this rule tells me, okay, if the parameter name equals EMX surface function and the parameter value equals cylinder counterbore and the container, so my group cool single counterbore has several parameters like BUW component equals E2072, supplier equals Moisburger, component type is cooling, then please use a different color, which is this purple color, which has a higher accuracy. Okay, so it's possible to create basic color rules, but also override these rules with even more detailed rules for certain components. So this depends on your own rules within your companies, but also like rules here for Moisburger, special rules for Moisburger. Yeah, so this is possible. So I think this gives you a good idea how these rules work in general. And our EMX configuration contains already a lot of different rules, and you can just have a look to them and use them as a reference in case you want to apply different other rules. Okay, so if I go back to my apply rules section, we also have the opportunity to create symbols. So this will be flat to screen symbols, and this is quite nice because then you see on one, just on the side of your part what these colors mean. So there's the RGB value, but also it tells you if it's a fit or what the position tolerances or the surface quality values are for these colors. And you can use the combined states at the bottom of the graphic window, and you can also switch back to the default. Yeah, so this is quite nice because then in case you do this all manually and you colorize your default, then you cannot switch back and forth. So you have the colors, and it can happen that this is a very that it's not easy to understand what the different colors mean. And so here it's quite easy to switch to in between the different states. Okay, so yeah. Beside these manufacturing context, we have added another context which can be quite helpful, which is called SMARTColor properties. And this context will colorize the part in a different way. So it will just, depending on the type that created the cutout, it will colorize the cutouts differently. So everything that's created by a guide component will have a purple color. Ejectors will have this shabby yellow or whatever it is, right? So if I apply these colors, you will see now that here are 3 different component types already created. So there are coolings, there are screws, and there are guides. Okay, so this is what can be found here. So you can switch in between these states and go back to the default state. So this is what can be done now. Okay, to show you now in a second step a little bit more detailed component, which is not just a demo part. I will just close my current components and clean up my memory. And I've just prepared, now it's also a demo part, but it's it's basically part of the cavity plate, which is part of our current EMX 12 tutorial. And you see here, if you open the part, that this plate is already a little bit more, is a bit more complex. Okay, so you see there are ejector pin holes, there are different screw holes, there are 2 cooling channels, and so on. But the great thing now is that you don't have to go from part to part and have to colorize everything by yourself. You can just go to SMARTColor, go to Apply Rules, say Manufacturing Context, Apply, and it takes a little longer because there are more features inside the plate. Create symbols, and close. Okay, so now my screen is a little small, so we have here it switches over with the annotations. But the great thing now is that all components that were created by EMX are now fully colorized, and this can be done with all parts that were created inside within this project, and this saves a lot of time if you have to do this compared to if you have to do this all manually. Okay. Now you see here that obviously not all surfaces are already colorized. For example, the pockets here for the insert parts are still transparent. And now you can use the manual selection of SMARTColor to choose from the same color palettes or color categories. And we have integrated a couple of handy tools here where you can now select or colorize surfaces quite easily. So this is not so it's way better compared to the standard colorization mechanisms that come with Creo. Okay, so I will choose now here, for example, the FDWF tolerance plus minus 0.002 millimeters. I can say select surfaces, and then I can just jump from surface to surface and colorize them. Okay, and they have now the same information content as if they were created with the rule set. Okay, same here for all rounds. They need a different color. So this depends on your what you want, for what tolerances you want. So now, as the designer, you might even know this better than me as a developer. So, okay, I can say okay. And now I can update my symbols and say create symbols. And you see here that the symbols are adapted. So all missing tolerances are added to this overview. And then you see here different tolerances, and you can go on and finish the whole plate. And of course, you can also enhance your rules that maybe other parts of the or other surfaces that are not covered at the moment will also automatically colorized. But from our experience, it's mostly impossible to automate everything. But in the end, if you have automized 80% and you only have to do 20%, manually, and also with a very nice and handy tool which is integrated in one software. This is it's more fun to do these kind of tasks. Okay, good. So this was my live demonstration, and I will just switch back to my presentation. Okay. Yeah, as a summary, it can be said that this parameter EMX surface function is very nice because it's independent from fixed color values. So in case, for example, you have colorized UDFs which have for each surface a fixed color, this is a lot of effort to just record all these UDFs. And with the surface function parameter, this is completely independent from fixed colors. Okay, so changes in case your color coding rules might change for some reason can easily be modified in SMARTColor then. Okay, and if you update the rules with SMARTColor, all changes will also be applied to the parts. So it's not a big effort to customize EMX on this. Okay, and it's also quite nice that you can implement different company standards with different colors quite easily in SMARTColor, which was not possible in EMX before. Okay, yeah, then we are ready for the Q&A session. I hope that there are many questions coming up. And yeah, then I'll just ask my colleague Sasha if he has something for me that I can answer.
Hello together. Yes, it was a very nice demonstration, I think, for everybody. And yes, we have one question, but it's also answered by Thomas, but I ask him again. It is possible to set different rules for the same UDF created by different suppliers.
Mm-hmm. Yeah. This is something I already answered. So because we now have only these parameter which describes the surface function, you can assign any color to the surface function that you like to have. And you can also use SMARTColor in a way that you have different contexts, like I showed you before, the properties in the manufacturing context. And you can also maybe think in different other contexts, like different company standards that you would just have. If you maybe work for two different companies, you can save the two contexts in your configuration and then colorize in a different way. So.
It sounds nice, yes. So I see there are no questions anymore, so I will say it was a nice meeting and no questions. It's good.
Okay, and thank you, Sasha. All right. Yeah, we have a couple of more webinars coming up this afternoon and also tomorrow and on Thursday, on the 10th of October. The next webinar will be about smart electrode. So this might also be interesting for all mold makers because electrode design is usually quite connected to the mold design. And tomorrow we will have a couple of more tools to be showed. It's Smart Update, which will tell you how you can update older parts to newer context. So yeah, this might be interesting for all administrators. And also if you're more interested in how SMARTColor works, you will find a webinar tomorrow at 4 p.m. Okay, then if you have questions, you can contact us directly. We have our email addresses. You can find them here at the bottom. If you are interested in having a demo license, this is not a problem. Just write us an email. And what's also quite interesting for you might be our newsletter. and also our YouTube channel, especially for EMX customers. We usually upload videos about what's new in the software, and it's a nice source to improve your workflow in EMX. Okay, we will send you an email with the recording of this webinar, and yeah, a short survey will follow also afterwards. And so I can just thank you for your attention. It was great to have this webinar, and yeah, I wish you a good week.